Hello physics, today we're going to do a big ol' energy problem. Okay, so it involves a toy rocket. It's going to go places, alright? First thing we know about it is that its speed is 5 meters per second at this height of 1.5 meters. Okay, we'll find its mechanical energy really quick here. So that's just going to be potential plus kinetic. It has a height and a speed, so we'll just need all the data. But we got its mass, speed, height, everything's going to work out fine. Okay, so I'll do this quickly. Okay, I get an energy of 64.9 joules. Okay, so at this moment in time, at this height, 1.5 meters, the toy rocket has 64.9 joules of energy. Now what we're going to say is that its engine provides thrust 35 newtons over displacement of 10 meters. Okay, and then it cuts out. Okay, I'm going to make that clear. So the engine then cuts out and the toy rocket's on its own. Okay, so the first thing we'll do is determine the work done by this thrust. And nothing tricky going on here. We have the force, we have a displacement, so we'll get the work done. But what I want to point out is this 350 joules is added to the 64.9. Because remember, the work is the change in mechanical energy. This thing already had this much energy from before we started our analysis, and it's just added 350 joules. Okay, so the rocket's new mechanical energy is what it had before plus the 350. Okay. All right. So we're going to find the rocket's speed at a height of 11.5 meters. Now, I just want to point out that this isn't tricky either. It started at, or we started our analysis at 1.5 meters, this much energy, and then the displacement of the thrust was 10 meters up. Okay, so when the engine cuts out, that is this 11.5 meters. Okay, so we know that the mechanical energy is 414.9, and that's potential plus kinetic. Okay. The potential, mgh, we know all those values. Okay. The only thing we don't know is v, so we are going to be able to solve this. The key assumption that too many students neglect is that it already had this much energy. Okay, because I'm going to have you do a question just like this in the assignment. Don't forget about the energy it started with.
What are you watching on your TV, Daddy?
I'm making a video for my physics class. How are you doing, Oscar? Okay. All right. So I've put in these values here, and we're just going to find out what v is. Okay, so when I multiplied all these guys together, I got 282. 1/2 of the mass would leave me with that. So I'll just sort everything out over here. 414.9 minus 282 equals 1.25 v squared. Okay, so I subtract, divide, square root. I'm going to get v is 10.3 meters per second. Okay, so like this is the most interesting question I'll ask here. I just want to go through it one more time. This is how much energy it had before we talked about the thrust of the engine. This is how much work the engine did. So this is the energy added. It's the total mechanical energy this thing has. but part of its potential, part of its kinetic. We get the potential there. Subtract, divide, square root, I got 10.3 meters per second. The last thing I'm going to ask you here isn't going to be nearly as interesting or involved. The maximum height the rocket may reach is just when all of this mechanical energy is potential. It's going to go up, 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 and stop. Kinetic energy will be 0. Okay, so the mechanical energy is just equal to the potential energy at the top of its trajectory. All right, so if we solve this, it's going to work out. So I'm just going to divide, and I'll do that fairly quick. Okay, I get 16.9 meters.